When you clean a vacuum cleaner, you become a vacuum cleaner. Applications involving vacuums aren't terribly uncommon in spectroscopy, but the cool thing about fiber optics is you can usually send the light through the fiber optics from the vacuum environment to the spectrometer that's in the ambient conditions. But sometimes the spectrometer does have to be exposed to the vacuum, but no one ever wants to test this because they're afraid something terrible is going to happen. So let's test it out. So we got here a vacuum chamber and a setup with an SR-4UVV spectrometer and a mag light. Let's turn on the mag light. We will carefully put on the lid. We'll take an initial snapshot of our spectrum and hit the switch. No, I'm just kidding, it was totally fine. But check out this spectra change. It did drop a little bit. Watch this drop when we turn on the vacuum. But with the vacuum off, it looks to start to recover. And unfortunately, there's no way to know whether this is from the spectrometer or the flashlight. Oh wait. But if we put the light source on the outside, we can see the effect on just the spectrometer. And now watch what happens with the light source on the outside. So we see the spectrum increase this time instead of decrease. But again, it looks to recover as soon as you turn the vacuum off. Honestly, this was most likely due to a lensing effect from the cover with the plastic warping as the vacuum is pulling on it. But the key takeaway is that the spectrometer recovered in both cases, so it returned to its original signal, showing that nothing internal was compromised during that vacuum exposure. And this is my favorite part of vacuum tests, pulling the plug. Whoosh.